Hello. In this video, we are going to prove trig identities. Before we begin, let's go back and review the trig identity. So I do have included this reference sheet in our class. So make sure that you mm, you go ahead and open the canvas. You should be able to see it. So these are our reciprocal identities. These are our cosine identities. These are our Pythagorean identities. And these are our sum and differences identities. And these are our double angle identities. So let's look at the example. In this example, I'm going ahead and start with the given from the left side. So I'm going to start with now before we begin, on the left side, let's go back to the identity. We have to use the sum identity. Okay. So we are going to use the sum of tangent. So tangent A plus B is tangent A plus tangent B divided by 1 minus tangent A times tangent B. So I'm going to go ahead and use this sum formula for the tangent. So I'm going to start with our given. So our given will be tangent of 3 pi over 4 plus theta. So that will be our given. And what we want to prove is that we want to prove that the left side, we start with the left side and we want to prove that the left side will be equal with the right side. So this will be our goal. Okay, so the next step, we are going to use the sum for the tangent. So I'm going to go ahead and make a quick note right here. We are going to use tangent A plus B is tangent A plus tangent B over 1 minus tangent A times tangent B. Okay. So in this case, our A is 3 pi over 4 and our B will be theta. So let me use different color so it's not going to confuse you. So this will be tangent of 3 pi over 4 plus tangent theta over 1 minus tangent 3 pi over 4 times tangent theta. Okay, so now the next step, we are going to substitute tangent of 3 pi over 4 for -1. So now what we have here will be -1 plus tangent theta over 1 minus -1 times tangent theta. And the last step, we just have to simplify our denominator. So 1 plus tangent theta. And if you can compare the answer, we compare what we have here with the right hand side exactly the same. So we just complete our proof. Okay, let's move on to the next step. So I'm going to move on to the next example. Okay, so in this example, again, we want to verify the trig identities. So I'm going to go ahead and start with the left side, and the goal with that, when we complete our answer, have to be the right hand side. So let's begin with the left hand side, which is sine of pi over 2 minus theta. So that will be our given. Now, if you go back to the trig identity reference sheet that we give it to you, we are going to use the differences of sine. So sine A minus B equal sine A cosine B minus cosine A sine B. Okay. So in this case, our A is pi over 2, so sine of pi over 2 cosine theta minus cosine pi over 2 times sine theta. Okay. Now the next step, we are going to substitute sine pi over 2 for 1 and cosine pi over 2 for 0. So therefore, we will have 1 times cosine theta minus 0 times sine theta. So we simplify that to give us just cosine theta. And we're exactly the right hand side. So we just complete the proof. Okay, now let's move on to the next example. Okay, so now again, we are going to prove this identity. We start with the left-hand side. So this will be our given. Now we go ahead and use the sum formula for cosine. Cosine A plus B is cosine A cosine B minus sine A sine B. So in this case, our A will be theta, our B will be pi over 2. So therefore, have cosine theta, cosine pi over 2 minus sine theta, sine pi over 2. Next step, we are going to substitute cosine pi over 2 for 0 and sine pi over 2 for 1. So that will give us cosine theta times 0 minus sine theta times 1. And simplify, so that will give us negative sine theta. And that's exactly what we see right here on the right side of the given identity. Okay, now let's move on to the next example. So in this example, the first step is that we have to pick one side to begin with. So go ahead and start with the left-hand side. To prove this identity, I'm start with the left-hand side. So sine of 2x times tangent of x divided by 2. So that will be our given. Now the next step, we are going to use the double angle, so sine of 2 theta. So I'm going to make a quick note right here. We are going to use the double angle, sine 2 theta, or sine 2x. Sine 2x equal 2 times sine x cosine x. So I'm going to go here. So sine 2x now become 2 times sine of x cosine of x, and copy the rest. Okay, so now the next step, before we cancel the 2, just leave it there for time being. The next step we are going to use, which is going to go ahead and use the cosine identity. So I'm going to use the cosine identity tangent is sine divided by cosine. So here we copy everything else. May I go ahead and use different color here so it'd be easy for us to see. So 2 times sine x times cosine x, except with tangent now. For tangent, I'm going to go ahead and replace or substitute by sine divided by cosine. Then copy the rest. So now you can see right here. Okay, so now you can see right here that the cosine will be gone. So now we will, and of course, I know that you will say, why don't we just cancel the 2? But hold on, we don't want to cancel the 2 yet. Okay, because the goal that we try to get to the right hand side here. And the next step now, I'm going to have to multiply. So after we multiply, that will give us 2 sine square x divided by 2. Okay, so what we just did right here, we just simplify, which is we cross out the cosine x, and also we multiply the sine x with the sine x. Now the next step, now we are going to use the double angle for cosine. So right here, I'll make note here. I'm going to go ahead and use the double angle cosine of 2x equal 1 minus 2 sine square of x. Why? Because you can see right here that it leads up to 1 minus 2 cosine of x here. So therefore, we can rearrange this identity. So therefore, we can conclude that if we add 2 sine square of x to both sides, so 2 sine square of x equal, and then also subtract the cosine 2x from both sides of the equation, so be 1 minus cosine 2x. Okay, so therefore here, now we can substitute. Now we can substitute the numerator by 1 minus cosine 2x and copy that the denominator. Now you can see what we just found here, exactly the same as the given right hand side of this identity. So therefore we just complete the proof. Thank you so much for watching. Goodbye.